Section 8.7 is going to talk about the sum and difference of squares. So, difference of squares, I'm not sure what that might mean to you, but what it means to a mathematician is you've got two things that are squared and you're subtracting them, hence the difference of squares. So, probably one of the most famous / infamous, most important factorizations that you're going to see in this course. And it's pretty simple. If you have a squared minus b squared, that's going to factor into a minus b times a plus b. A very useful, handy factorization. Now that's the difference of squares. We can also look at the sum of squares. What do you suppose the sum of squares is going to look like? Yeah, just the same thing except a positive sign between them. A squared plus b squared. Not much different, right? Pretty similar. Although a world of difference in terms of what you get when you look for the factorization. That one's prime. Now that bothers some people because they're like, well, wait a minute. You mean we can't multiply things together to get that? And the answer is yes, we can't. You can try different things. A lot of times people say a squared plus b squared is a plus b squared. And look, I get it. It looks like you should be able to distribute this. That's not true. But if we followed through on this, it'd be a plus b times a plus b, which is a squared. Outside terms give me ab. Inside terms would also give me ab plus b squared. Does this and this add up to 0?
No.
What does it add up to?
AB is squared.
Well, I'll tell you what. They're like terms, right?
So
I've got one of them here and one of them here. 1 plus 1 adds up to 2. So 2 AB. And that's not equal to this. So, okay, that doesn't work. And you could try putting in a minus here. And the only change you're going to see is you'll end up with a minus down here. So then you say, all right, well, I'll do one of them positive and one of them negative. But oh, wait, that's what this factors as. So try as you might, you're not going to find anything with real numbers for which you get the sum of squares. So for now, it's just prime. So we'll have to keep that in mind. Now the first example is me just giving you, a little vocabulary, that this is the difference of squares. Typically speaking, you're going to see stuff like this, and you're going to be asked to factor it. What's helpful to notice is that 36 is a perfect square, and 49 is a perfect square, and you start looking at this a little more critically and saying, oh, well, 36 is 6 squared, and x squared is, x is part of that, also squared. So you get that minus 7 squared. So that's writing it as the difference of squares, but let's go a little bit further with this one. Makes sense. This is a good one to start off by practicing. Understanding this, I can write that as 6a minus 7, or excuse me, 6x minus 7. Can anyone fill in the blank? What would the next one be?
6x plus 7?
Yeah, 6x plus 7. And that's it. There's your factorization. Of course, they're not looking for something quite so much there. They're just looking for this cheap answer right here. But that's okay. It's all right to do a little bit more here. Now, I smudged out these things right here. This one gets misunderstood a lot. So if you don't want to get this wrong on your homework, then try and pay attention here. Because a lot of people write this out as something which it's not. The real point of this is to figure out that this is the difference of squares if I regard the first term as being, say, I don't know, what would you square to get 9y squared?
3y.
3y. And that's it. It's 3y squared. you know, and on your copy of this wasn't bleeded out, but it's just the answer, 3y squared. How about over here? What would you square to get 4m to the fourth? Well, let's start with the coefficient. What do you square to get 4? 2. And then you've got to square something to get m to the fourth. And that takes a little bit of thought. So let's see if we can't figure that part out. You've got m to some power, and you square it and get m to the fourth. That has to be a 2, because 2 times 2 would be a 4. So it would be 2m squared. And that's it. That's all they're looking for, is to say, well, what are the terms you square to get each of these? Now, the one below it is kind of foreshadowing things to come later in this section, where we start dealing with cubes. And on the board, you've got a list of your first 10 perfect cubes. What do you cube to get 125? 5. And then this one would be an h. So 5h to the third power would give me this. How about 216? What do I cube to get 216? 6. And now I need to figure out the rest of this. It's going to be k to some power. Well, what power of k do I cube to get k to the 6th power?
3.
No.
Or 2.
2. Because these are going to multiply. So 2 times 3 would be 6. So that's going to be a k squared. And if I take 6k squared and cube it, I'll get 216 k to the 6th. And that's all they're asking for here. Now, I'm not going to give problems like this, but there's a few in the homework. So just be on the lookout for them. Your problems, here's a good slate of problems. So all 5 of these down here. Let's see if we can't bang out a few of these. Starting with kind of a nice, friendly, easy one over here. When you look at these things, first thing you should think about is, all right, well, what do I square? I mean, is there a GCF? Is the first thing you should look at. There's no GCF here. So, Jocelyn, help me out here. What would I square to get this first term?
3y.
3y. So put a 3y here and a 3y here. How about this second term? What do I square to get there? 4. Gustavo, how does this finish up? I got 3y and 4, 3y and 4. I need to fill in a little bit here.
I gotta figure out if it's gonna be plus up. And then
Both plus? All right. Plus and minus, or minus and plus. Either way, it doesn't matter. As long as one is positive and one is negative, that's all that matters. Thanks, Gustavo. And thanks, Jocelyn. Let's try the next one. You try the next one. You've got 25y squared minus 49z squared. There's no common factor here. Bummer. It's nice when there's a common factor. You can make your life easier. So you look and you start seeing, oh, well, there's only 2 terms. So you start thinking, well, maybe that's the difference of squares. And you start asking, well, what do I square to get the first term? I square to get the second term. Carvel, maybe you can help me out. What would we square to get these terms?
5y.
5y and
Negative 7z.
7z. All right, so 5y minus 7z. And then what would the other part be? What the next binomial?
positive 7.
5y plus 7z, right? So you're just switching the signs from one binomial to the next. A minus b times a plus b. What if Carvalho gave me 5y plus 7z times 5y minus 7z? What if these signs were switched in his paper? Should I mark them wrong?
No.
You guys are too generous. All right, you're right. Yeah, and it doesn't make any difference as to which way you put the signs, just as long as one of them's negative and one of them's positive. The next one is supposed to be easy, but people get this wrong all the time. What are we gonna do with this one?
A plus 3.
A plus 3, A minus 3? Colby?
I'd say A minus 3 to try to get to a positive.
A minus 3? A minus 3, A times A minus 3? Okay.
Always
Right.
prime.
Oh, Ian says it's prime. Well,
Well, you know, there's not two squares.
some of two squares, and that's so tricky to look at that and go, oh, because you're seeing the squares, you're seeing the perfect squares, you're in a groove because you've done a lot of these, and all of a sudden, oh man, they're throwing me a curveball. This one's prime. Of course, when you enter that in WebAssign, it's just going to be a squared plus 9 here. Let's just be kind to ourselves. It's just prime. Okay. The next one is a classic one to expect from me. Let's see about doing this one. So I'll give you a minute to look at that. If you're watching this later, you can pause it and unpause it, whatever you need, but see if you can come up with that factorization. So you get 2 points out of 4.
Okay.
That's good. That's only 2 points out of 4.
Oh, I see.
Yeah. Yeah, so we gotta keep it. 2 points out of 4. Okay, it's 2 points out of 4. Oh, that happens. Should probably be a 4, because 2 times 2 is 4. 4 times 4 is 16. But you're still gonna have to get the digits in once you correct that.
I know it's 4. But you can't. This is 4. 4 and 4.
4 and 4. 4 and 4 is a good start. And
No, it can't be 99 for someone.
then 9 and 9, that's gonna work. But you need a little bit more. Is that a square or a square?
It was gonna be, and I was getting rid of the square, because I didn't know where to put
No,
it.
the square should be there.
Oh,
Alright, but it's not gonna be the end all and be all of your answers.
okay.
Okay, so what you should be doing and thinking when you do these problems is thinking about your factorization strategy. There's no GCF here, right? So after you factor out the GCF, if there is one, and you look at what's left, how many terms are there?
2.
There's 2 terms. So that brings you down this left branch. Are those terms squared numbers or are they cube numbers?
Square.
They're squared numbers. So it brings us down this branch. And now either it's the difference of squares or the sum of squares. If it was the sum of squares, we'd be going, woohoo, hey, we're done, just like this one. But it's not. It's the difference of squares. So you start factoring it and you're like, okay, well, let's see. What would I square to get 16?
4.
4. And then I got an a to the 4th, so this will be an a squared. Minus, what do I square to get this one? 9
Squared.
b squared, and 4a squared plus 9b squared. And there's at least a dozen of you that I walked around and said, great, that's 2 points out of 4. Now, all those people I said 2 points out of 4, did anyone figure out else why or what else you got to do to get those extra 2 points? Sterling, I think it was, I'll get you the next one. What's that?
You can take it further than that.
Yes, you can take it further than that. What else would you do?
Multiply.
Emmy?
You would just keep factoring down.
Keep factoring. Good. This one, full factor some more, right? Again, it's the difference of squares. So, Rachel, what would I square to get this?
2A.
2a minus what?
3B.
Times what?
Same thing. 2A minus 3B. Or 2A plus 3B.
There you go. Got to change that sign to a plus 3b. How about this one? What happens with this one? Pearl, can I do anything with this one?
Same thing.
Same thing, 2a minus 3b times 2a plus 3b, or, but Pearl said no. Which one is right?
Or that's a prime number.
Oh, is it prime or can I keep factoring it? Which one?
It's prime.
Sarah, do you want to settle the score here? No? All right, well, at least that's honest. All right. What we got? Ryan? Can I do anything with this one? Yeah, Ryan here.
I don't know, maybe factor it.
Maybe? No? All right, somebody be bold. What do we got here? Can I factor this?
No.
You just rewrite it?
Yeah, you just rewrite it. How come I'm just gonna rewrite it?
It's prime, it's the sum of the squares.
It's the sum of squares again, right? It's prime. Now, if you ever watch a lot of movies or read some books, a lot of times you'll see, the criminal leaves the scene, but behind the camera focuses in on a book that's on the shelf, and that book's going to be a clue for later on. Basically, it's foreshadowing. This is some foreshadowing for you. I like these problems on exams. I don't know how more blunt I can be about that than just now. So look for stuff like this, okay? Because it happens. I like the double factorization because it tells me that you recognize the difference of squares. It also, in the same problem, tells me you recognize the sum of squares can't be factored. So it's a good problem. Now, this last one over here is really in the same spirit as all the rest of these. It just looks different. Before I get onto that, are we okay with this one here? So this is your final answer. This is the 4 points out of 4 points that I'll award on this problem, not the 2 points up here.
Excuse me. How would you check it?
Oh, how would you check it? Great question. So if you wanted to check it, what you could do would be multiply these two together first, and then you're gonna get a product, and then multiply those two together after that. And you should get back to where you start. And I'm seeing kind of like, are you sure? Is that gonna work? Let's do it. So good question. So 2a minus 3b and 2a plus 3b and then 4a squared plus 9b squared. So I'm going to start out just focusing in on these terms right here. All right, so we're going to leave the 4a squared plus 9b squared out to the side just for the moment. All right, so help me out here. If I multiply these together, come here. 2a times 2a gives me what?
4a squared.
4a squared plus
9b negative, or, yeah, 9.
6ab minus 6ab minus negative 3 times 3 is minus 9b squared. So far, so good? All right. Is there any simplification I can do here?
Combine like
Yes.
terms.
There's my like terms, right? 6 minus 6 is 0. So really what I'm left with when I combine the like terms is this. I'm left with 4a squared minus 9b squared times 4a squared plus 9b squared. So I multiplied the first two together. Now, I use the brackets just so that you could distinguish brackets and parentheses and group things a little bit better. But they mean the same thing, and I'm going to FOIL the same way. I'm going to get 16 a squared times a squared is a to the 4th plus 36 a squared b squared minus 36 a squared b squared minus 81 b to the 4th. And kind of like the last one, those middle terms cancel each other out. What's left? 16 a to the 4th minus 81 b to the 4th. So, wow, it worked. So, great question. Great question. I've seldom been asked that one. Anything else on this one? I think we proved that we got it right, so that's a good thing. This isn't really much different than any of these other three here. Obviously, it's not a sum of squares, but it's kind of the same thing. Now, what did we do when we did some of these earlier problems? We asked ourselves, well, what did we square to get this? What do I square to get this? Well, you can do the same thing here. What am I squaring to get the first term?
And then
M plus n. That's what you're squaring. Just m plus n. Minus. Now what do you square to get that next term?
P squared.
P squared. So m plus n minus p squared times what? We got the first binomial. Can anyone tell me what the second one's going to be?
plus n plus p squared.
M plus n plus p squared. And if you're curious, you don't need to write the extra set of parentheses. I do that because I'm treating this as one whole term. But you don't need to. If you wrote it in on WebAssign as m plus n minus p squared, m plus n plus p squared, that's fine. That's exactly right. Writing it like this makes it a little bit easier to see that this is the difference of squares factorization, but you don't have to. There's nothing wrong with that. Okay, let's do a few more here. Let's try example D. And in thinking about my list of perfect squares, I realized, oh, wait a minute. 8's not a perfect square, and neither is 32. So how am I going to factor this as the difference of squares?
Find the greatest common factor. Squared.
Thank you. Let's take out the GCF. Last year, GCF in this one is
4. Or 8.
8.
Yeah.
So if you factor out an 8, what's that leave behind? Caitlin, what's left behind if I factor out the 8?
B
3x squared,
Mm-hmm.
and then the minus 32.
No. You're factoring the 8 out of there. 32 divided by 8 would be 4. Great. Now I'm done, right? No? What else? Emmy?
It would be 8 times x minus 4, x minus 2, and then x plus 2.
Perfect. So once you factor out the 8, you leave that 8 alone, and then you finish it off as the difference of squares. Beautiful. Beautiful. Thank you. Let's try again over here. Example E. Suggestions on this one? John, how would you start on example E?
Factoring out an A.
Factoring out an A? Okay, we could do that. So if I factored out an A, that would leave behind A times 3c to the 4th minus 48. Not much I can do here. There is one little thing you can do. It's going to make all the difference in the world. Have I taught this class the trick for deciding if something's divisible by 3? If you add up the digits of your number, like 4 plus 8 is 12. Is 12 divisible by 3?
Yeah.
Then so is this. So what I'm saying in kind of a roundabout way is that 3 is also a common factor here, and you could factor out a 3 as well as the 8. So let's take out a 3 and an A. Ryan, G, and back. What's that leave behind if I factor out a 3A?
C.
C to the 4th
16.
minus 16. Great. That's looking a little bit more doable here. So see if you can't finish it up. 3A. And keep going.
What do you mean? C squared minus 4.
All right, so we got a suggestion of c squared minus 4
C squared plus 4.
and c squared plus 4. I like it. Sterling.
Could you keep simplifying it?
Excellent. Well done. Which one simplifies?
The c squared into c minus 2 and plus 2.
Perfect. This one's the difference of squares again. So you're seeing the same kind of thing for me again, that something factors twice. C squared minus 2, C minus 2, and C plus 2, and then C squared plus 4. You have to keep this term on here at the end, even though this one factors into 2 other terms. So that's what I'll be looking for. This, of course, will give you partial credit, but I want you to get full credit. So do look out for that one. Okay, time to expand our horizons a little bit more. And we're going to work with the difference in sum of cubes. Are we good on example E? All right, let's finish up with the sum and difference of cubes. So the sum of cubes, that would be something like a cubed plus b cubed. Let's see. And then difference of cubes would be a cubed minus b cubed. Now let me be very clear about something. This is never, ever, ever, ever going to equal a plus b cubed. That's not the way this thing factors. Nor is this a minus b cubed. Keep that in mind. Let's look at how these things really factor. And I'm going to start out by writing down just the terms in the factorization. So, okay, here we go with the terms. Start out with an A and a B. And down here below, I'll do an A and a B. Now, if you notice, one of these sets of parentheses is wider than the other one. That's because you've got a binomial times a trinomial. 2 terms times 3 terms. So what are those 3 terms? A squared, AB, and B squared. And down here, A squared, AB, and B squared. What do you think about these terms, or about these formulas so far? Is there anything you could remark on these?
It looks a lot like when you, like earlier when you did the squared, like you put the square on the outside
Okay.
of the equation.
How do these compare to each other so far?
They're the same.
They're the same. They're exactly the same. The only difference is the sign. And to figure out the signs, we've got this little pattern. SOAP. These first 2 signs are always the same. So that's a plus and that's a minus. When I'm talking same, I'm referring back to the sign of whatever it is you're trying to factor. What do you think the O is for? Nice, opposite. So that's a minus, and the last one is always positive. Same sign, opposite sign, always positive. See if you can't fill in the signs for the rest of this. Pearl, what sign should I put in here?
Minus,
Oh, no, wait.
add,
Plus?
That's the middle plus.
Plus and plus. Now, the SOAP part, that's really helpful. There's actually a little part that helps me more than this, and that is 1 negative sign per customer. I catch more mistakes with this than I do with the other one. Because if you write something with no negative signs, or 2 negative signs, or 3 negative signs, you know there's a mistake. It has to have exactly 1 negative sign to the right of the equal sign. So that's our general formula. Now you can remember it as is. I would suggest you remember the SOAP and maybe this little mnemonic device. Bonus points if you can spell mnemonic. But let's see about factoring some of these things. All right, so that brings us down to example F. This is the difference of cubes. You should get used to your list of perfect cubes. So things like 2 cubed is 8, 3 cubed is 27, 64, 125, 216, 343, 512, 729, and 1000. So anything on this list, those are your perfect cubes. And when you start seeing these numbers, you're like, oh, okay, that's, maybe the difference of cubes or the sum of cubes. What would I cube to get that first term?
2m.
2m. So let's just put a 2m here. Don't worry about the signs just yet. What do I cube to get x to the 6th power?
Squared.
And x squared, because 3 times 2 gives me 6, so an x squared. My suggestion in these has long been take these two terms to generate these three terms. So how can I do that? Well, I'll take the first term, 2m times 2m. I'll multiply this by itself. What's 2m times 2m? 4m squared, thank you. 4m squared. I'll do the same thing over here. I'll take the x squared times itself. X squared times x squared. Someone else, Hannah. X to the fourth. And finally, I need something else in the middle. I've already done this times itself, this times itself. So my trick in the middle is to multiply this times this. So it's going to be 2m times x squared, and that's just going to give me a 2mx squared. And I don't worry about the signs until I'm all done with that. Are we okay with how we got that trinomial? Sarah, maybe you can fill in the signs for me. What signs are going to go here? Here, here, and here. Same sign, opposite sign, always positive. Same sign, opposite sign, always positive. Yay, and that's it.
That was easy.
Yeah, sweet. All right. Let's try example G. Well, 625, that's not on my list of perfect cubes. I don't get it. So I mean, 625 is 25 squared or 5 to the fourth power, but none of that helps me out. What's a way to start on this one?
Divide, or like,
Lowest common denominator, or the common factor.
Yeah, GCF. What's the GCF in this one? What's the common to both of these? 5? Jameson, if I factored out a 5, what's that leave behind?
x or z cubed
Z cubed plus, it's all right, yeah, smart move, take out a calculator.
125.
125. Nice. So hopefully you look at that, we factored out the GCF. You worked your way down this decision tree. It's got two terms. They're cubes, so you branch over here. And because it's the sum of cubes, you get down to this formula here. So we've already got the first two terms. Well, actually we don't have the first two terms. Carvel, what do I cube to get each of these? What do I cube to get the first term?
Maybe 5.
Right, this is going to be a 5 here. How about this term? What do I cube to get that?
Z.
Z. Z cubed gives me this. Now, just as before, take each of these terms to figure out what the remaining three terms are. So for instance, Z times Z. And then work with the 5, and then work with both of them. Try and fill out the rest of these. So, if you're watching at home later, pause it, try and fill that in completely. second would be theta to the fifth. These. Okay, so this term times itself to be this one. So this term times itself to be this. This times this. So I'll move this a little bit. Jeremy? So you can see what we did here.
Alright, thank you.
Okay, so to get this last term, you're taking this times itself. So it should be 5 times 5, right?
Okay, yeah, okay. Okay, because I see.
And then the middle term, what do we do to get the middle term here? We took this times this. That's how you get the middle term. You multiply those two together.
Okay, thank you.
Okay, so the middle term is really this number, this times this. 2 times the x squared. That gives our middle term. So what would that be here? Also like z times 5 or turn around. Z times 5, so z times z is z squared. And then, so we need to keep doing the same thing here, Carvel. So in this one, once we had these two, we took the first 2 times itself to get that term. The second 2 was this times this. That gave me x to the 4th. The middle term is this times this. So you gotta do that same thing down below. You're missing a term. It's always going to be a binomial times a trinomial. You've got a binomial times a binomial.
Okay.
So you're missing a term from there. You're going to have to use our sum of cubes formula. Do you have that written down someplace?
Yeah, over here.
Okay, you might want to look at that a little bit.
Okay.
Okay, so kind of repeating what we did up here. You take the first term times itself. Z times z gives me z squared. You take the last term times itself. 5 times 5 gives me 25. And then you take this term times this term. Z times 5 gives me 5z. There's just one last thing left to do, and that's put in the signs. These two signs are the same. These two are opposite, and the last one is always positive. So plus minus plus, and there you have it. Nice. Let's do a couple of problems by way of wrap up. What would you do if I gave you 49x squared plus 36y squared to factor? Does that factor as 7x plus 6y, and 7x minus 6y.
No, it's a prime.
Ah, if I had 49x squared minus 36y squared, that's how this was factored. This one is prime. Who's saying you, why is it prime?
Because it's added together.
Yeah, because of that silly little addition sign in here, it's messing everything up. You can't factor it, it's prime. This one we did on the reverse side, so we're gonna skip that one. What's your thoughts on doing this one? How do we do that one? What's your general thoughts? I mean, you don't have to give me specifics, but what's your general thoughts? How's that one gonna work out?
Both are square.
Well, the perfect cubes.
Over.
Yeah, both of them are perfect cubes. So it's gonna factor as a binomial times a trinomial. And you gotta figure out, well, what do I cube to get this? What do I cube to get this? Bless you. If you don't know that list of perfect cubes, then it's not a big deal. What you can do is take out your calculator and go, you know, that looks familiar. You can do the cube root. If you haven't seen a cube root in a while, here it is. You hit the math key, fourth option down, gives you the cube root. Cube root of, say, let's do 125 since we already got the 6 up there. Oh yeah, 125 is 5 cubed. 216 is 6 cubed. And you can use those to fill this in. So see if you can't do that one last one for the sum of cubes. Jocelyn, what do I cube to get each of these terms? What should I put in the first parenthesis here?
6A.
6a. And then what else? 5b.
5H.
All right, so 6a plus 5b. Use these two terms to come up with these three terms. So for instance, if I want that first term, Rachel, what am I multiplying together to get the first term here? Some help?
6A.
6a times 6a. Just take the first term by itself. So it gives me 36a squared. Lauren, how about the last term? What do I multiply by itself to get the last term?
You multiply 5B times 5B.
Yeah, 5b times 5b. Good. And what does that give me?
It would be 25B squared.
25b squared. Perfect. There's one last term that I need here. Caitlin, what's that last term? What am I going to do put together to get that last term?
6A times 5B. And then
6a times 5b gives me
30AB.
perfect, 30ab. Nice. John, can you finish off the signs for me?
It'll be a plus, a minus, and a plus.
Good. Same sign. Up sign, always positive. Not that you need to write that, but there it is. And this is your answer. This is your final answer here. And to answer your question, Kaylin, that you haven't asked, but I know what you're thinking, you could check this by distributing. If you multiply the 6a times all three of these terms and the 5a times all three of these terms, if you added those up, everything would cancel out except the end terms. So you could, again, you could check that you got it right. Okay, let's put that one to rest.